When you open Instagram on your phone, you watch a little spinning wheel, and instantly a fresh feed of photos and videos appears. Your phone didn't generate those posts. It sent out a digital request to a server sitting hundreds or thousands of miles away, asking for that content to be delivered. Early software was built as a single massive block of code, but as systems scaled, that block fractured into dozens of independent pieces. Today, an application is stitched together from separate systems: maps from Google, payments from Stripe, and user data from a database. To make all these moving parts work together, they need a common language. That is the Application Programming Interface, or API. It acts as a secure translator, allowing entirely different systems to negotiate and exchange data. Without a standardized way for servers to communicate, the modern internet breaks apart into isolated islands. This layout shows the 4 core action verbs of HTTP, the foundational language of the web. Get fetches data, post creates it, put updates it, and delete removes it. Curious instructional tone. Let's look at how a standard GET request is actually constructed. First, you need an exact destination address, the endpoint URL, so the network knows which specific server to contact. Next, you add highly specific instructions called query parameters. These act as filters, ensuring the server sends back only the exact 10 items you want, rather than dumping thousands of records onto your device at once. Finally, the request needs a secure ID card. In the header section, we attach a JSON Web Token, or JWT. This is a compact encoded string that proves who you are and what you are allowed to access. Because this token carries its own mathematical signature, the receiving server can verify your identity instantly, skipping a slow, expensive database lookup altogether. This standardized grammar allows any 2 machines, even those written in completely different programming languages, to securely exchange data in a matter of milliseconds. As you see in this flow, REST is the standard Q&A format of the web, but it forces a rigid exchange. When a client asks for a specific piece of data, the server often returns a massive, rigid payload, forcing the client to overfetch or underfetch what it actually needs. To fix this data waste, developers adopted GraphQL. Instead of relying on static endpoints, the client sends a precise blueprint, and the server returns exactly the interlocking fields requested. When you move deep into the backend, speed takes priority over human readability. For internal server-to-server communication, engineers use gRPC, a highly compressed binary format optimized entirely for raw speed. This visual highlights WebSockets. For live gaming or chat interfaces, standard request and response polling is too slow. WebSockets keep a persistent, open connection between client and server, allowing data to stream instantly in both directions. If you want to avoid constantly asking a server if an event has happened yet, you use a webhook. It reverses the flow entirely. The server calls your client only when a specific trigger occurs. System design requires matching the exact right architectural dialect, whether you need precision, raw speed, or a persistent connection, to solve the specific bottleneck in front of you. A raw API endpoint is just a function sitting on a server. Exposing that directly to the open web is incredibly dangerous. This diagram shows the API gateway in action. It acts as an intelligent bouncer sitting directly in front of the server logic, intercepting every single incoming request. It enforces strict rate limits, preventing massive traffic spikes from crashing the system, and it automatically drops any request carrying an unauthorized API key. Without an API gateway, the entire backend infrastructure remains completely vulnerable to sudden traffic surges and direct external access. This fragmentation is exactly what the Model Context Protocol, or MCP, is designed to solve. It acts as an open, universal standard for AI integration. This diagram illustrates how MCP works. Instead of hundreds of custom integrations, these scattered tools adopt the standard MCP shape. Now any AI model can seamlessly communicate with any external data source using one unified language. An API is the precise connective tissue of the digital landscape. Whether you're loading a simple photo feed or orchestrating a next-generation AI agent, APIs remain the invisible nervous system dictating the flow of human technology.